In this lesson, we're going to discuss dilution and how we use the dilution formula. First, we need to define the difference between dilute and concentrated. These are relative or comparisons between two solutions. The solution on the left we would describe as more dilute because it has less solute, and the solution on the right we would describe as more concentrated. These all have the same volume, but we see less solute in the solution on the left and more solute in the solution on the right. When we do a dilution, such as in the lab, what we'll see is that we have the same amount of solute, but more solvent. When I look at a sample, what I see is that the volume increases as I go from the beaker on the left to the one on the right. However, the amount of solute particles does not change. This is known as a dilution because it creates a solution which is more dilute and it will have a lower concentration of the solute in the solvent. The dilution formula helps us calculate the different concentrations and volumes and how they're related to one another for a solution. C1V1 equals C2V2 is our formula, and you may see this as M1V1 equals M2V2. These are exactly the same. The M and the 1 and M2 refer to molarity, whereas the C1 and C2 refer to concentration, so it's a broader definition. But either of them work exactly the same way. We'll have two solutions. Solution number 1, or our initial solution, and solution number 2, our final solution. When we're reading problems, we need to be careful to make sure we sort the data correctly. C1 is our initial concentration. V1 is our initial volume. C2 is our final concentration, and V2 is our final volume. When you're going through a problem, it's helpful to make the two sets of data and sort them so that you can see what you know and what your unknown is. The units for C and V can be anything as long as C1 and C2 have the same units of concentration and V1 and V2 have the same unit of volume. In this course, we'll look at our concentration unit only of molarity, but we'll see different units in volume. It may be liters, milliliters, kiloliters, and it doesn't matter which one we use as long as V1 and V2 have the same unit of volume. Let's look at an example. 1.25 liters of 6.0 molar HCl is diluted to a final volume of 10 liters. What is the final concentration? The first thing I'm going to do is make a column for initial and final so I can sort my data. You have to read the problem carefully to make sure you pair up the right volume and concentration. They aren't always written together. I know that I'll have C1 and V1 and C2 and V2. In my initial solution, I have a volume of 1.25 liters and a concentration of 6.0 molar. My final solution has 10.0 liters and our concentration is unknown. That's the value we'll be solving for. I plug in the values into the equation, so 6.0 molar times 1.25 liters equals C2 times 10 liters. Doing the calculations, I get 7.5 equals C2 times 10, dividing both sides by 10, and we get C2 equals 0.75 molar. And this is a reasonable value. When we do a dilution, going from the initial solution with a higher concentration to a final solution, we expect there to be a lower concentration. Sometimes we'll see where we're given two volumes that we actually have to combine in order to find the final volume. There are cases where two liquids combined do not equal the sum of their individual volumes, and these are known as non-additive volumes. And this results from the way the two solutions interact and mix with each other. We also have additive volumes. In this case, the volume of the total combined solution equals the sum of the parts. Unless we're told otherwise, we will always assume additive volumes. What volume of water should be added to 50 milliliters of 8.0 molar NaOH to make a solution with a concentration of 2.50 molar? In this case, we need to be clear about what the problem says. It's asking about how much additional water, how much additional solvent should be added. We're still going to take the same approach. We're going to get our initial and final information. We have 50 milliliters for our initial and 8.0 molar for our concentration. For V2, it's our unknown, so we put a question mark there. We know it's going to be in milliliters because our initial solution is also in milliliters, and we need to have them in the same units. And our concentration is 2.50 molar. Now we can plug in the values, 8.0 molar times 50.0 milliliters for C1V1, plug in 2.50 molar for C2, and leave V2 as our unknown. We get 400 equals 2.50 V2, and 160 milliliters equals the final volume. Note that this is the final volume, not the amount of water that should be added to the 50 milliliters. We're starting with 50 milliliters. We're going to go to a final volume of 160 milliliters. So we need to subtract 160 minus 50 to get 110 milliliters. The final volume is 160 milliliters, but we need to add 110 milliliters to get to that final volume. 110 milliliters is the volume added. Which problem can be solved using the dilution formula? C is the correct answer. What is the concentration of a solution prepared from the addition of 25 milliliters of water to 50 milliliters of 2.0 molar HBr? Notice we're seeing that we're just changing the amount of solvent. We're not talking about a chemical reaction. There's only one thing in this solution, and we're simply adding more solvent. When we look at A, what we see is that we have one condition compared to C, where we had two conditions. We had some initial and final state. When we look at A, it's asking about the moles present in a solution. There's no change in the volume, no change in the concentration. So this is not a dilution problem. Same thing for B. We have one set of conditions, therefore this is not a dilution problem. C has two conditions. We're adding additional volume to get to our final volume, and we're going to see a new concentration after we have a different initial concentration. For D, what we're doing is comparing two solutions, but we're not going from one to the other. This is also not a dilution problem. What volume of water must be added to 25 milliliters of 0.750 molar NaF solution to create a 0.450 molar solution? Note that we're trying to find the amount of water to add to our original solution. Again, we're going to summarize our data, initial and final. We have 25 milliliters initially and 0.750 molar NaF. We're trying to find the final volume of the solution, and we're given the final concentration of 0.450 molar. We take C1 times V1 equals C2 times V2. We get 41.7 milliliters equal to V2. This is the final volume, not the amount of water that needs to be added. We need to go one step further and take 41.7 milliliters, which is our final volume, minus the volume we started with of 25 milliliters, and get 16.7 milliliters to determine the amount of water that must be added. So B is the correct answer.